各位荧幕前的观众朋友，业界先进，大家午安，大家好，我是外贸协会产业拓展处电子资通讯组詹宗宪。今天研讨会的主题是欧洲 5G 专网与智慧工业应用。本次研讨会将深入介绍 5G 在欧洲及智慧制造的发展。欧洲是我国通讯产业第二大出口地区，全球通讯大厂 Ericsson 及 Nokia 也都来自欧洲。欧洲还是汽车工业及制造业大本营。欧洲如何应对 5G 新浪的来临，也将影响我国相关产业的未来。为此，我们邀请了德国专业电信杂志副主编及两大通讯巨擘 Pehrsson 及 Nokia 在智慧制造的主管，分享 5G 在欧洲及智慧制造的发展。然而，在活动开始前，欢迎各位帮我们按赞、分享、订阅冒协 YouTube， 并开启小铃铛，确保冒协最新影片不漏接。首先，我们来介绍第一位讲师，德国 B2B 电信通讯专业杂志 Telefonica Handel 副主编 Mr. Boris Boden 为大家讲解德国 5G 及产业发展。
Hello everybody, welcome to Germany. My name is Boris Boden. I'm Deputy Editor and Staff of Telekom Handel, a leading publication for telecommunication, retailers and professionals, which has a website and also a printed magazine. Today, I will talk to you about 5G in Germany and the business opportunities that arise from this. Let's speak about the German mobile communication market. We are a nation of 83 million inhabitants, of which 86% of the adults now own a smartphone. So we can say the market is pretty saturated. There are more than 150 million SIM cards in circulation. Many people own several cards, contracts, and there is also a growing number of M2M SIM cards. The market size comprises 22 million smartphones that are sold annually in Germany. This market is not growing anymore, but people do replacement and they own several smartphones as well. The tablet market is 4.5 million annually. Last year, this grew by 12%, which is quite interesting after years of stagnation. The tablets were acquired during the COVID-19 crisis as additional media terminals and also for remote schooling. If we talk about 5G, we have to talk about regulation, because nobody can set up a 5G network if he doesn't have the permission by a federal agency. This is called Bundesnetzagentur, or you would say Federal Network Agency in English. This agency grants licenses for 5G spectrum by auctions. The last auction in 2019 was for 2.0 and 3.6 gigahertz bandwidth. 4 network operators acquired licenses and paid for this. Next licensing will probably be about microwave band. It started in January, but the allocation is still pending, and it's not really clear who will acquire licenses. This will probably be the big network operators, but could also be smaller operators. So this will be an opportunity, and it has to be watched. There's also the additional possibility for licensing company networks, so-called campus networks. This is politically intended in order to help Industry 4.0 developing in Germany. The take-up was a bit slow, but currently more than 110 licenses have been granted, mainly in 3.7 and 3.8 gigahertz, which has been specially allocated for this by the agency. Big companies like BASF and Bosch, and also German car manufacturers, have all acquired licenses for campus networks and set up these networks. I'll come to the use cases later. What are the political conditions for 5G in Germany? Well, we can say that Germany is not, in politics, is not the most digital-minded country on earth. Many politicians really don't have it as a prime topic on their agenda. Some others have, but it hasn't been so much in the focus. It changed a bit during COVID-19 crisis. because here the need for fast internet structure, for remote work, remote schooling, etc., was really obvious. And now it's getting more and more important, we all hope. The Bundesnetzagentur, the Federal Network Agency, has defined targets for mobile broadband coverage for operators. This is not explicitly 5G, but it can also be done by 4G if bandwidth is high enough. It means by 2025, almost 100% of the population in the area of Germany has to be covered with mobile broadband. This was also a precondition for licensing. The government sees 5G especially important for the development of Industry 4.0. It now is seen that there's a problem in covering the whole country economically, because network operators have to make money by operating, of course. So the government has established its own infrastructure company that will erect antenna sites where no commercial viable coverage is possible, especially in rural areas. We'll then offer these sites to the use of these sites to the network operators. And of course, at the moment, there's a discussion that was mainly fueled by the development in the USA about prohibiting or restricting several network suppliers, mainly Huawei, which is where all these discussions are going on about the security of data and about political questions. So far, there's no clear decision on this. Network operators are still allowed to buy and use equipment from this vendor, but the discussion will go on. One alternative could be Open RAN technology, which is also promoted by the government. This means that more equipment can come from different smaller vendors for the radio access network. It offers a big business opportunity for network suppliers that could also be from your country. Coming to the network operators, which play a crucial role in Germany for everyone who wants to work with 5G. Currently, we have 3 4G network operators in Germany, but we will have 4 when it comes to 5G. They are all roughly the same size, with about 50 million active SIM cards in the market. The largest still is Deutsche Telekom, because it's very dominant in fixed line networks. That is because Deutsche Telekom, some 40 years ago, had a monopoly on the German market as a state carrier. It has a 5G coverage of 50,000 antennas, but they are all non-standalone, so they are mainly using 5G as well, in 2.1 and 3.6 gigahertz. The second one is Vodafone, which is part of the British Vodafone group. Vodafone has 7,000 antennas on air. They are using 3.6 for their network in the large cities, and they are converting this network to standalone as the first network operator here in Germany now. They're also using 700 megahertz on rural areas with lower speed but larger area coverage. The third is Telefonica Germany, using the marketing name of O2. This is part of the Spanish multinational group Telefonica. They have 1,000 antennas on air in 700 megahertz, 1.8 and 3.6 gigahertz. They are much smaller than the others in 5G because they started almost 1 year later than everyone else, just in last November. But now they are developing fast, and they are the first ones to implement Open RAN. And there will be a 4th network operator. It's a company called 1&1 Drillisch, which is part of the German internet service provider United Internet. They have 5G licenses for 2.0 and 3.6 gigahertz, but they don't have a network so far. They want to start this year, and they're using a national roaming agreement with Telefonica in order to get their customers also to phone on other areas where they don't have their own 5G network. They will build up a 5G standalone network based on Open RAN, so this could also be interesting, perhaps to become a supplier of this company. What are the trends and the upcoming agenda in 5G? The transformation to 5G standalone and Open RAN has started with operators. Vodafone has the first 5G networks they are converting their 3.6 gigahertz networks in the cities to standalone now. And Telefonica will follow this year. But the Telecom is a bit slower. Open RAN is in trial. Telefonica has now started to convert the first sites, and they will also develop this. But it will take some time probably, and will be a topic for the years to come as well. Fixed wireless access with high bandwidth and microwave is also only in trial in Germany. It is very expensive to bridge the last mile for fiber, fixed line fiber, from the curb to the building. So here, microwave access could be an alternative. There have been trials going on mainly by Telefonica in Hamburg, but at the moment it's not commercially available in Germany. But this will change in the upcoming years as well, and could also be an opportunity for suppliers, for vendors of infrastructure, but also for terminals like 5G routers and these things. And there are more and more campus networks, not only for industry, but also for research and developers. For example, the Hannover Fairground, as you probably know from former visits of CeBIT and Industriemesse, is now covered by a campus network, which is operated by Deutsche Messe and Telekom. And here, companies can also set up a portal to develop industrial applications. Siemens is one of the companies who are doing this right now. So if a company from Taiwan wants to come to Germany and wants to test their network equipment under real circumstances, they could talk with these people. There are also campus networks at universities now, and you can test your services, your equipment in accordance with German conditions. And the marketing of 5G for consumers is still slow. Many consumers are not aware of 5G and the possibilities. But the COVID-19 crisis changed this a bit, because many people now see this as a backup for the fixed lines, which are not always stable and not always working properly. So some people see, okay, 5G will be an alternative, and this will be probably a market driver for the next years. So what are the business opportunities in 5G? I've outlined in red what I see as the principal possibilities for companies. Of course, there's the network equipment. Currently, Ericsson, Nokia, and Huawei are the dominant suppliers of German network operators. But the market will be opened by Open RAN and by campus networks. So more suppliers could come into place to offer hardware, but also routers and other equipment. Of course, you have to go through network operators for this, and system integrators, for example, for campus networks. But this will be a business opportunity. Then there's the hardware itself. The German smartphone market is considered to be one of the toughest in the world, because it's very much high-end driven. The average selling price of a smartphone in 2020 was 499 euro. So this is quite a lot compared to other countries in Europe. The dominant players are Samsung, Apple, and Xiaomi, with Huawei now losing track because people don't want to buy smartphones without Google services on these phones. Companies from Taiwan have also been active on this market. HTC once was very popular, while Acer has stopped selling smartphones but is successful with notebooks. And Asus sells also still present and selling smartphones in small numbers. The smartphone market also implies a huge market for accessories, like power banks, covers, headsets, and these things. So here there are opportunities. If a company from your country has interesting products on offer, they could go through telecommunication or IT distribution networks and sell these items on the German market. And there is still a limited choice of 5G-enabled tablets, notebooks, and IoT devices. Especially the tablets are interesting because they are often used in industry for AR applications. But the market is very limited. So far, there has only been one Samsung tablet and now the new iPad Pro. But here, vendors could also have a chance. And 5G modems and routers were very much in short supply during the COVID-19 crisis, because consumers had a very limited choice of these devices. There's mainly one Huawei router that is sold by all network operators for 4G and 5G. But here there is surely a market demand for new products by alternative vendors. 5G services for consumers are still very much in development. Fields like AR, VR, and also gaming are not really tailored to 5G, but this will change in the coming years and could also be a business opportunity. And then there's the large field of the industrial sector for 5G. And 5G, I told you, 5G plays a crucial role in this. I think the most important sector for business opportunities is the industrial sector. It comprises, for example, 5G controlled manufacturing, robotics, autonomous transport systems, location-based services, and asset tracking. I can give you an example of a use case in industry. For example, Bosch Rexroth, which is a company, a car parts supplier, a large electronics company. They are using autonomous small transport vehicles in their companies, in the manufacturing halls. And these have sensors which respond to 5G in order to navigate around people working there, to navigate around other vehicles as well. And this all happens by 5G in their campus networks. So here the security and the speed of the network is crucial for this application. Another application, for example, is used by Lufthansa Technique, which is an aircraft maintenance company in Hamburg. They are using their 5G campus network, for example, for augmented reality on tablets. It means when they have to equip the interior of an aircraft with seats and everything, the workers can see on their AR tablets how it will look like in reality. So this is an important aid for their work. Or for example, for inspection of aircraft engines, they are using video by 5G in high resolution, because now it's not necessary anymore. No technician, from example from Boeing, flies in to do this. Now they can do it remotely with video cameras over their 5G network. These are only some examples. There are many more in manufacturing, especially the car manufacturers are very keen on using this. For example, asset tracking is used by car manufacturers like Audi. They can put 5G modules on their cars, which are manufactured and then put to storage before delivery. They always know where these cars are. It's not necessary anymore to do a manual control where the car is, to note where the car is. You can always track this with a 5G modem. And there's many more to come. So this is a big business opportunity for companies who have 5G controlled machinery, who have 5G enabled tools and these things. Then there's the transport sector, which is also very important. Here we are talking about autonomous driving, which is now possible with 5G standalone because of the low latency. All German car manufacturers are on this topic. They are perhaps not as far as, for example, Tesla in the United States or many companies from Asia, but they are all developing this and they are also testing this. So far, this is very regulated, autonomous driving on German public roads, but the development will change in the years to come. Smart traffic is another topic. Then setting up the infrastructure for electric cars, because now electric car market is growing in Germany, it's growing fast, but the infrastructure is not, well, there's no unique infrastructure to load your car. You need apps from different suppliers, from electrics companies, from cars companies. It's very complicated. So to set up an infrastructure which is easy to use by everybody, this infrastructure must be based on 5G. And this is a huge project. It's also the same about car sharing. The access, the control of vehicles will be much easier with 5G. So the transport sector, especially the car industry, will be a very important customer for 5G. And then there's the public sector. Public sector is slower to adapt to new technologies in Germany because, and it's also difficult because we are federal state. For example, education is not the responsibility of the national government, but of the countries in Germany. So sometimes the structures are difficult to get by who is really responsible, but it can be very rewarding because now large deals can be made in public sector also with 5G. For example, rescue services. Now German rescue services like the firefighters are starting to use 5G enabled drones to operate in dangerous areas. This is one example. Sensoring in smart cities is a big field where it's now growing, but still it's not a mature market. Cities are using these technologies now, for example, for sensoring air quality, for sensoring traffic, also for security, for surveillance. So this is a huge market for hardware, but also for service developers. And remote education. Remote education wasn't a topic at all before COVID-19, really. But now this has changed totally because most pupils in Germany are at home now. They have to learn at home. They have to use the networks their parents had, mainly a Wi-Fi and then fixed line, and they have to use hardware. They have to use notebooks and also very often tablets. Some schools are providing this for the pupils. Some have to buy it for themselves. But it's a huge market, and now it's growing so fast that the system operators are not catching up with the possibilities this market has, also for hardware. It's very much dominated by Apple and Samsung, considering hardware sales. And I've listed the medical sector. Remote consultation of doctors by video has just started in Germany because many people had problems with offering their data and everything. They thought it wasn't safe. But this is also changed by COVID-19. And this sector is also growing very much. Patient monitoring, for example, by using devices like fitness trackers, could also detect dangers, health dangers, and cause the doctor to intervene. All this works much better with 5G because you can use more of these devices in the network, of course. It will be a market for future as well. The same about emergency call system with location-based services. This will also be facilitated. So medical sector is growing, not as strong as the others, but it's very promising. And there are many more use cases to come, like for example, agriculture, which hasn't been addressed so far, but will also be a topic in the future. Vodafone is working much on this. So to sum up, you see there are many business opportunities in 5G. Yes, it's a difficult market. It's very much regulated. It's also very dominated by the network operators, but there's a huge demand for services, especially in industry with the campus networks, and there's a huge demand for 5G hardware. So it could be interesting for you to come to Germany to invest in these markets. If you have any questions, don't hesitate to contact me by email or visit our website. Regrettably, it's only in German. Thank you very much. Goodbye.
非常感谢 Mr. Boden 与我们分享德国 5G 的发展。再来，第二位讲師是 Ericsson 副總裁兼政府與產業關係負責人 Mr. Pehrsson。歡迎 Mr. Pehrsson。
Okay, thank you for that introduction. And it's great for Ericsson to be invited to this important TITRA event. For me, it's a pleasure to be back and able to contribute once again. And today, I would like to talk about the subject, Be Unlimited with 5G, the Industry 4.0 connectivity engine. And I will start today by updating you on the state of play of 5G, the fifth generation of mobile technologies, now being rolled out globally at a very high pace. and with Ericsson as the main contributor and driver globally, and also including in Taiwan. So I will then focus on today's subject, what 5G technology can do for smart manufacturing, and how Ericsson is ready to work in partnership with a very strong Taiwanese industry. But first, let's look at the fast uptake of 5G, primarily in 3 regions, as you can see, first quarter of 2021. And that's in Northeast Asia, including Taiwan. You see also in North America, primarily US, and you see in Europe. And this is all based on 5G speed tests in quarter 1 of this year. And of course, we're comparing with the situation only 18 months ago in Q3 2019. So we can now see that 5G is growing fast and is actually growing faster than previous generations of mobile technologies. So then, looking at 5G in numbers, globally, as you see on the upper half of this slide, you can see that there are now more than 130 live 5G networks around the world. And there's already more than 700 5G devices, commercial 5G devices available. And already now, 5G networks cover 25% of the world's population. And then focusing on the leading 5G nation in the world, namely South Korea, you see that the average monthly mobile data traffic per subscriber is as high as 24 gigabytes. And already nearly half of mobile traffic in Korea is now run over 5G networks. But if you look at the lower half of this slide, you can see the Ericsson numbers when it relates to 5G. And as you can see already now, Ericsson plays a leading role in the global 5G rollout. At the end of April, we power 85 live 5G networks around the world, more than any other vendor, of course, including in Taiwan. And Ericsson also leads in 5G commercial agreements and the number of 5G standalone networks. Ericsson is also the 5G innovation leader with the highest number of standard essential patent contributions to the 5G standard. And Ericsson, we are ready to walk the talk. We are the only vendor with local manufacturing of 5G radios in the United States. And at Ericsson's 5G Smart factory in Lewisville, Texas, we are benefiting from 5G connectivity on the factory floor. And results are already impressive. As you can see, we have 120% improved output per employee, a 65% reduction in manual materials, 24% reduction in energy consumption, 75% reduction in indoor water usage, and all of this powered by 100% renewable electricity. And the World Economic Forum, WEF, has awarded Ericsson the Global Lighthouse Award in recognition of the Ericsson site in Texas being a global leader in the 4th industrial revolution. So, looking at the global situation, together with Arthur D. Little, Ericsson has estimated the potential global value of smart factories and smart manufacturing. The manufacturing industry represents approximately 16% of the world's global GDP, and that includes everything from large aerospace factories to local microbreweries. And the baseline factory is medium-sized and quite normal in terms of digital development, with the goal to represent an average factory. And to simplify, we can say that the global manufacturing GDP represents approximately 140,000 average factories of this nature. And for each average factory, the yearly steady state net value of applying smart manufacturing is estimated at roughly $6 million. And if we then look at the global value potential with this reasoning, the global yearly value from the use cases would be approximately $840 billion. This is then the potential value that factories around the world could take part of if deploying the smart factory use cases. And we are convinced that the potential value for Taiwan of smart manufacturing would be significantly more important than the global average you saw on the previous slide. And this, of course, based on the fact that the industrial sector in Taiwan has twice the weight of the global average, more than 36% actually, compared to the 16% you saw on the previous slide as the global average. And looking at the structure and composition, as you see on this slide, of Taiwanese industry, with leading sectors being electronics and related industries at 37%, and metal machinery and equipment at 21%. This also strongly indicates that Taiwanese industry will be a major beneficiary if adopting smart factory solutions. Many studies clearly show that manufacturers face several challenges in their current operations. Everything from increased demand for customization, stagnating productivity, shortage of competencies, and not least challenges to data security. And this at a time when production and machinery data carry a growing share of the actual value in manufacturing. So clearly, smart factories are able to address many of the key challenges for manufacturing companies. And the bars on this slide show an assessment of how large share of specific factory tasks that today are made by humans, that is the gray share of the chart here, or by machines, and the machine part shown in the orange part of the bars on this slide. And as you can see, only a minority of tasks are automated today. There is, however, potential to automate the majority of tasks in 2028, as this study shows, as technology advances and factories become more willing to adopt new technologies. And actually, based on a survey of manufacturers conducted by MAPI and Deloitte last year, 86% believe smart factory initiatives will drive competitiveness in the next 5 years. So thus one can argue that embracing the automation opportunity and other smart factory initiatives is important for manufacturing companies to actually survive. So factory managers experience that it's difficult knowing how to get started with smart factory initiatives. And this slide shows just some of the smart factory use cases which could be beneficially deployed. And the use cases are divided into a number of use case clusters based on Ericsson's 5G for Business potential study. There are actually 9 clusters, but the 6 shown on this slide are the most relevant for manufacturing. And those are autonomous robotics, enhanced video services, augmented reality, AR, monitoring and tracking, real-time automation, as well as hazard and maintenance sensing. And while factory managers often are aware of that there are a lot of use cases to go after, it's more difficult to actually know how to get started. And in this slide, and I will not go through them, you see a range of very specific applications and use cases that will be enabled in a smart factory, and of course for the smart factory owner to identify which would be the most relevant for exactly those manufacturing operations. And we can also see that evolving industrial and enterprise trends together drive the need for robust connectivity. For example, the need to integrate multiple separate networks for communication used today. We also see that innovation shifts from core applications to the edge. And of course, edge applications will be strongly supported by 5G capabilities when it comes especially to low latency, fast response times over networks, enabling new applications and new solutions. We also see the proliferation of IoT, Internet of Things, and we also see a growing demand for high-speed data applications. So today, Ericsson is actually offering two alternative solutions for smart factories. One which is customizable for on-premises configuration, and the other one is a pre-packaged solution for easy installation and designed for scale from the very start. So we see, just flip through here on this slide, so we come to that one. We see clearly a transition when it comes to digitalization across industries, from silos to an ecosystem of ecosystems, if you like. And to a great extent, the industry is already connected, but still in silos. So when it comes to turning insight into actions, it's important to see that we are releasing the potential confined and limited to today's information silos, and this requires a unified and agnostic ecosystem, a hub that enables all real-time data to interrelate regardless of whether it comes from within the network or from other sources. And that is enabling true Internet of Things, IoT, based on 4G and 5G technologies. So what we see is that the Ericsson Partner Program brings together like-minded people to get to ensure seamless and secure industrial IoT and to get the most out of Industry 4.0 business opportunities. Partnerships and new ecosystems are key to unlocking the full value of 5G and Industry 4.0. No company can unlock the full value alone. So working with service providers, system integrators, software and application developers, chipset and device vendors, gateway suppliers, cloud providers, and various standards organizations, Ericsson is bridging the gap between the devices and the applications. And becoming an ecosystem partner helps you to unlock new business, grow your business, earn certification, and gain valuable access to new customers. So, to sum up, Ericsson is welcoming partnerships with Taiwanese companies, and be they service providers, software and application companies, professional services companies, and not least, looking at the pure strengths of Taiwanese industry, device and hardware companies. So you are welcome to join the Ericsson Industry 4.0 partner program, and we bring together like-minded companies to get the most out of industrial business opportunities created by 5G private networks and smart manufacturing. So once again, you are invited to establish contact with Ericsson, and you have here the contact details for Ericsson Taiwan for follow-up and detailed questions. Thank you very much for your attention.
非常感谢 Mr. Pehrsson 与我们分享 5G 在工业 4.0 所扮演的角色。第三位讲师是 Nokia 垂直制造全球主管 Mr. Richter。欢迎 Mr. Richter.
Hi everybody. I'd like to thank you for the opportunity to present today to you. I have prepared a presentation to talk about how we as Nokia may support you to enable the next level of the digitalized production. Nokia may be known to you already because we are a supplier of telecoms equipment to all the Taiwanese communication service providers. But what we also do is that we have been able to supply the enterprises directly with a dedicated enterprise organization. For this, we are focusing on specific verticals, as you can see here. We supply government and cities, we are active in energy, we are active in transportation, as well as to the web scalers. But the newest kid on the block is also manufacturing and logistics. Manufacturing and logistics is focusing on the process and discrete industry, as well as on the automotive industry and logistics as said. For this, we have a global organization with which we serve all our customers around the globe. And we make use of our partner ecosystem in that we have different channels to the market, but we also partner with industrial partners and strategic alliances to combine our forces and to provide the best of breed in services, solutions, and applications. Let us talk about today's challenges of manufacturing and logistics as we see it and how these challenges can be addressed. It is a long-term issue that manufacturing needs to improve efficiency and productivity over the time again and again and again to stay competitive. And this means that all the manufacturers want to maximize the uptime of the production equipment and to minimize business interruption in order to reduce cost. But this needs to be combined now with a high production flexibility and agility, because the vision and the ambition is that the manufacturers can produce a very customized product at a lot size 1, so a single product at the cost and at the quality of a mass production. For this, obviously, the research and engineering quality needs to be up, and the collaboration between the R&D departments and the engineering departments need to be very close. And results from R&D and engineering needs to be transferred to the production straight away. And this means that for that agility, you need the right data to be available, because you want to do a very fast decision making, and the fast decision making to stay competitive here needs to be based on data availability. That data availability and those fast decisions also need to be made in a very diversified partner ecosystem, because a lot of the production today is outsourced either to suppliers or even to customers. And that whole value chain from the supplier to the manufacturing to the logistics partner and then straight down to the customer, all this needs to be incorporated in that decision making and needs to be incorporated in that flexible production scheme. However, also the requirements regarding health and safety for the workers, but also for the production equipment itself, are ever increasing. And on top of that, sustainability and green production is very high on the agenda these days and a need of the day. So to reduce carbon emissions, to reduce energy consumption is ever more important. And as you may have seen from the Hannover Messe 2021 these days, last week, many production managers have that on their agenda today already. What does it mean? This leads to increased factory and shop floor automation. This also leads to a need for data transparency and digital insights. This also requires real-time planning and agility for the planning and for the setup of the production facilities. In order to support the workers in such a scheme, worker augmentation and remote support is needed with real-time data, with real-time documentation, and with real-time work orders. And obviously all of this then requires a very reliable connectivity which is interoperable with all the different devices, machines, and ecosystems, and it needs a data exchange between those ones. The vision of that future network is that all goods are connected, that the network supports a very flexible layout of the production system, as well as the support of mobile assets, because more and more of those assets become mobile in that they can be flexibly shuffled around and set up in new configurations. This also requires a network which is able to support a cognitive supply chain, which is data fueled, which is intelligent in itself, and which is self-learning. Last but not least, it is about the connection between the workers collaboratively with the machines, which are either remotely controlled or are remotely operated. And again, for this, you need an ecosystem of technology as well as human beings in a very flexible manner. Are we alone with that vision? Certainly not. On the one hand side, we see the analysts saying that the wireless connections on a shop floor are taking over the fixed line connections latest in 2023. Also, our potential customers say, more than half of them say that a technology like a cellular wireless network based on 4G or 5G technology will be their choice to build such a network of the future, which is serving the ICT as well as the OT needs. How do we position such a network? On the one hand side, the public networks, the public service provider services, will always play a role in that game, because employees are connected as well as public services need to be available on the factory campus, in the plants, and need to serve the supply chains. On the other side, enterprise-controlled networks like LAN networks and Wi-Fi networks have been established already, and they serve the purpose for the current applications in the office, but also for basic data connectivity. But obviously, those networks are not good enough to serve the requirements of business-critical applications or even mission-critical applications. And in this area, where the OT requirements are dominating, and where we see the OT ICT convergence happening, exactly in these areas, the cellular wireless networks like 4G and 5G networks and industrial grade LAN are playing their dominant role. And this is what is at our heart to be provided with our cellular networks offering. Let's have a look at the use cases which can be supported, which can be enabled by installing such an intelligent network of the future. We have done a look at this in a structured manner, and let us start with the campus itself. On the Digital Factory campus, we see today and in the future use cases in the area of facility management, security and surveillance, and all these use cases lead to a digital factory twin, which is combining holistic view in a digital manner on the physical assets. This can be driven up right to the usage also of multifunctional drones, which is also part of our portfolio, for instance, to support the facility management or the security and surveillance tasks. When we go one level down to the shop floor, then here we will find use cases in the area of machine-to-machine communication, in the area of collaborative robots and cloud robotics, as well as a high need for intelligent use cases for quality management and quality assurance. This shall be data-driven. This is dominated by requirements for a network with very low latencies, and this is deterministic traffic which needs to be supported there. Not to forget the worker. As said before, we need to support the worker to play their role in that ecosystem. And here we see use cases from basic voice and video communication to other means of augmentation, like for instance, AR and VR, augmented and virtual reality, combined with remote expert support, and for instance, also connected wearables. So what we see here is that we allow the worker to have access to the intelligence of the corporation at their fingertips and at the place and at the time when they need that. Last but not least, we have thousands and thousands of dumb and smart assets which cry for connectivity, because even the cheapest asset, which is playing a crucial role in the production process, we need to be able to allocate that asset. We need to be able to say in which condition that asset is and how we can use it in a very flexible scheme. And for this, we see here use cases of asset condition monitoring. Based on that monitoring, we can arrange for predictive maintenance, or we can do the remote configuration and control of those assets. The more smarter assets, like the automated guided vehicles, for instance, they serve different purposes. It is not only the remote control of those guided vehicles, it is also that these automated guided vehicles can be used as the ears and eyes of the production manager on the shop floor. And again, connectivity is needed to link the data produced or the data used on the automated guided vehicle to be linked up to the cloud where the intelligence sits. And here we combine the use cases of an AGV with the cloud robotics on the right-hand side. For all these use cases, we as Nokia have a stake in the ground because our connectivity is an enabler for many of those use cases. Connectivity either being industrial fixed networks or industrial private wireless networks, or also connectivity beyond the campus with multi-site interconnect, or even a smooth and seamless global connectivity, which would allow you to track supplies as well as goods around the globe in a seamless manner. Can we as Nokia satisfy the need for these use cases on our own? Certainly not. We believe in a heterogeneous ecosystem of partners here, because we provide crucial parts for those use cases, in that we provide, for instance, connectivity or selected applications. But in many, many cases, we use products of our partners to complement and to satisfy a use case need from A to Z. Let's talk about the connectivity a bit more in detail. We have seen before that there is today a myriad of different devices, sensors or cameras, etc., which are available to gather the data or to use the data we produce. On the other side, we see software applications, software platforms, either sitting in the public cloud or in the corporate cloud or in hybrid clouds, or right on the premise of the factory, which provide the intelligence to deal with the data, which can either be captured or used by the devices. So how to get these things connected? Today we use cables a lot, and those cables will stay in place where they fulfill the needs. But for an automated guided vehicle, which is moving around, obviously the cable is not the choice. So many have started to use wireless technologies in different forms and shapes. So we see on the shop floor short distance wireless connectivity technologies like Bluetooth, but this is not good enough to let an AGV run across the whole factory. Others have started to use Wi-Fi for it, and they soon had to realize that Wi-Fi has not been designed, nor does it fulfill the needs of such a connectivity. It is not providing the performance and the reliability which is needed for a production process which is running 24/7. Therefore, we say there are better technologies available, and the better technologies are today 4G and 5G networks. And with 5G, obviously for the first time, a cellular wireless standard has been designed to fulfill the needs of automation tasks. For this, we have in the meantime products available to fill that gap in the middle. Those networks are designed to cater for the requirements in such an industrial environment. And in order to do so, we have now customized the kit in such a way that it is technically and economically viable in smaller form factors to be used. We benefit from the trend that a lot of functionality of those networks in the meantime is sitting in the software with virtual network functions, that the compute power of the servers has increased so that we can put a lot of these applications on single servers. And certainly we also benefit from the development of small cells, which we have driven over the last couple of years in such a way that we can bring with those small form factor access points the connectivity, the coverage, as well as the capacity to the places where it is needed in a very tailored manner. On that picture, you see one of the product choices of Nokia, which is called the Industrial Nokia Digital Automation Cloud. The specific feature of that product, which is only one of many, is that the control functions for the network here are sitting in the Nokia Digital Automation Cloud. Why is this so? What we have experienced is that this technology is new to the production managers and to the IT departments in the industry. In order to support the operation of those networks, we take away the pain in that we run the operations in the cloud. That cloud can either be our own cloud. This cloud can also be the corporate cloud, where the IT departments take over the control of those networks as they do for their production systems today. So we are very flexible. We are very, in a very flexible manner, we can support these functions. And so we can grow with the maturity of the organization. When we look at the 5G Hive, specifically also in Germany, and I want to talk a bit here about why Germany is at the forefront of introducing 5G, then we see different aspects of it. Firstly, driven by the vision of Industry 4.0, many of the companies, many technology leading companies in Germany, they have a need, they have a demand for industrial use cases today. They have figured out how they can use AGVs, they have figured out how they can use video analytics, asset management, etc. And therefore, they also articulate today a need for those use cases, which goes beyond what can be supplied with Wi-Fi or with 4G. So from a technology point of view, from a use case point of view, they are eagerly waiting for the new capabilities to be provided with 5G. Then we have 5G as a technology. 5G is available today with release 15, as it is called. Release 16 is eagerly awaited by the industry, because with release 16, which has been standardized already, and where we are at the moment busy to bring it into our products, release 16 is the first release which is catering specifically for the needs of industry in the area of ultra-low latency as well as ultra-reliability. Those are the features, those are the capabilities which are needed to replace wired machine-to-machine communication connections with wireless connectivity in such a way that also the safety functions can be supported. It is to talk about the support of the German ecosystem and German governance to bring that ecosystem and to bring these 5G capabilities alive in the industry. Today, we are in the luxurious position to have in Germany access to enterprise spectrum in the frequency range 1 and 2, means in the mid-band spectrum of 3.5 gigahertz, as well as in the millimeter wave spectrum with 24 gigahertz. This soon will also be the situation in Taiwan, and this is one of the very crucial ingredients to enable that ecosystem. On the other side, we see in Germany that so-called model regions have been set up, that there is public funding available to run proof of concepts, to trial the technology, and to allow the enterprises, the companies, to gain their first experiences. This is specifically of interest also for the small and medium-sized enterprises, of which we have a lot in Germany, which may see this new technology as something which is too far-fetched for them, or which is too complex. And exactly to bring down those hurdles, such a vehicle like the model regions are good to bring that right to the small and medium-sized enterprises, together with institutions like the Fraunhofer Institute, which is a binding factor between industry, customers, suppliers, and the academia. Last but not least, we see industry associations like, for instance, 5G ACIA, which have made it to their task to be a link between the ICT, the IT and communications industry, and the automation industry, to translate requirements, to mediate between those different requirements and how they can be served, and how companion standards can be set up to have templates and blueprints at hand when the industry wants to use the technology for their use cases. Other industrial associations, like the German machine builders, VDMA, they have set up specific work groups like the Wireless Communication for Machines work group, which work into the same direction, and again bring the partners together. Then obviously we have that huge potential of Industry 4.0. And here we see that 70% of all the enterprises invest into industrial IoT, which is a good rate to make use of all what I said before. We see that those enterprises try to enhance their efficiency, agility, and the decision making, and increase worker safety and sustainability furthermore. And they tackle to use those 74% of data, as analysts say, which are today already available, but are not collected or used yet. And with this myriad of a data lake, in which we can fish and find the intelligence, this is the vision of Industry 4.0 to bring ICT and OT technology together. It needs to be mentioned that the ICT and OT technology convergence is not only a technology convergence. This is also a convergence of different cultures. This is a convergence of different organizations. This is something which needs to be seen as part of the digital journey of an enterprise going towards Industry 4.0. So what needs to be considered when we plan, deploy, and operate those 5G networks, either as part of a public network, may it be a private slice in a public network, or as a completely standalone 5G campus network. What has been proven to be a successful approach here is that we say start with a proof of concept. Start small, start with a selected set of use cases, to gather the first experience and expertise. Usually those proof of concepts also can be financed with special purpose vehicles, and you have a little bit more flexibility and freedom to test in those proof of concepts because the commercial burden to show return on investment is not as hard as in the next steps for the deployment or the scale up, where obviously all the that technology does need to make commercial sense as well. But start small, start today, and then grow into the bigger deployments. In those deployments and scale-ups, we make use of the domino effect. We start with a single set of use cases, add new use cases to it, because this is the beauty of that technology, that it is a multi-purpose network which is provided there. It is not a network for a single very specific use case, and when you have a different one, you need a different network. The network capabilities are flexible enough to be used for many different things. And this helps to make these networks also commercially viable. Then it is about the scale up, that once those use cases have been implemented, they can be rolled out to different sites, even globally, because together with our partners, we have means and ways of finding the right spectrum in different countries, to find the right partners in those countries, or to be present ourselves, as shown in the very first slide, on a global scale. While the deployment takes place and while the scale-up takes place, that technology is upgradable, because with new releases, new features come on board, and new use cases can be supported. And it is an investment protection that the networks can be upgraded, mostly via software. And with this, once installed, it can be enhanced and extended in different directions. Let me talk about some experiences we've made and some references we have produced. First and foremost, we use that technology in our own factories. We have a number of them, and one of the examples is our factory in Oulu, which is a lighthouse project of the World Economic Forum, and where we have installed different use cases like the digital twin, like AGVs, etc. ourselves, and where we use our own equipment and our own implementation resources. Then today we are engaged in a number of research projects, as well as demo labs and collaborative laboratories. For instance, the Arena 2036 is a research area near Stuttgart in Germany, where the automotive industry is trialing and testing new production methods of the future. And together with many other partners, we provide a 5G network there for testing, trialing, and for the research of localization, for instance. We also run those centers with other partners like Accenture, or we have equipped the test lab of MyNXG, who use our equipment in their industrial IoT stack, which is a complete stack from A to Z, including an improved security layer. But we also have customer projects who use our products in a commercial manner. And I will come back to two of those references in a minute, talking about what we have done together with Bosch as well as with Lufthansa Technique. And then obviously we have partnered with industrial partners, because our solutions we try to combine with their solutions to have one solution off the shelf, for instance, with the likes of Omron or Dematic. And also for Dematic, I have the reference in a minute. Let's talk about one of those references. Lufthansa Technique. Lufthansa Technique is providing services to the airlines in that they do the overhaul of engines. One of the features there is the so-called table inspection. So when an airplane engine comes into Lufthansa Technique's hangar, then it is about to decide which of the parts of an engine needs overhaul, needs replacement, or can stay. So the engines are taken apart. The parts are laid out on a table, therefore it is called table inspection. And in the past, the customers of Lufthansa Technique came around personally to stand in front of the table and to decide what to do with the parts. Lufthansa Technique started a proof of concept to install a wireless network in such an environment already in 2019-20. And when the COVID-19 pandemic arrived, then all of a sudden that proof of concept turned into a commercial model, because all of a sudden the customers were not allowed anymore or were not able to travel to Hamburg. So Lufthansa Technique turned this into a commercially used use case, where you can see that with a high definition video stream, the customers are brought to the table virtually. So the customers could stay at home and they have the possibility to do the inspection remotely. The trick here is that this video stream needs to be a very reliable, high definition, high performant video stream in an environment which is an industrial environment, which is challenging to wireless networks. So Lufthansa Technique also tried different technologies, and it turned out to be the case that a 5G network at the moment is serving their needs in the best manner. With Bosch, one of our industry partners, we have equipped one of their factories in Stuttgart-Feuerbach with a 5G network. And a nice feature can be seen in the on-demand sessions of the Hannover Messe, where together with another partner of ours, with Reuter and Schwarz, we have showcased how this network had been installed and what performance the network is providing. This is a discrete production of automotive parts, and the network in that factory needs to serve Bosch's AGVs. You can see at the bottom on the left-hand side. Those are AGVs which take their intelligence from the cloud, and a reliable and performant connectivity of those AGVs with the cloud is crucial to make them work. Dematic is my last example in this course here. Dematic is a provider of warehouse equipment. And as you can see also here in the picture, this is an environment which is sort of hazardous to wireless networks, because it is loads of steel, it is loads of material in those shelves, and the products need to be taken out of the shelves in those very narrow passes here. And cabling of such a warehouse system is quite an expensive exercise. And on the other side, once sensors or cameras or whatsoever are cabled, they are inflexible, because to change them would need a recabling. So Dematic also trials different technologies, and again, a 5G network is today their choice to support the handling of their goods in such a warehouse system. And they combine our system with their system in the warehouse system to be provided to their own customers. Last but not least, I want to come back to our Oulu factory. As I mentioned before, the Oulu factory is an electronics factory where we produce our own access points. The Oulu factory is special in that we produce prototypes and early product variants. So flexibility is very high on the agenda of that factory, because they do not produce these access points in thousands for, say, half a year or so, but rather that the production setup needs to be changed on a weekly basis. And by introducing our own applications and our own products in that production, we were able to reduce, for instance, setup times to reshuffle the production line by more than 70%. And obviously, in using our own kit, we learn our own lessons, we gain the experience collaboratively with our colleagues over there, and are able to improve the setup and the design of our products for those needs. I see this very relevant because Taiwan is known for their electronics production and semiconductor production, and I believe for partners in Taiwan we have a good offer to be made here, and that we have experience in this area. With this, I want to come to the end of the presentation, and just to highlight that today we have more than 260 of those private wireless customers out there around the globe. Those customers come from the different segments I have shown in my first slide. So it is not from manufacturing, because manufacturing is just to take off. The majority of those customers are from energy or from transportation, but an ever more increasing number of those references will be seen also from the manufacturing segment in future. And with 260 wireless customers, we regard ourselves as a market leader in this area. And you are more than welcome to contact us to discuss your opportunities together with us for the Taiwanese market as well. With this, I would like to close. I would like to thank you for listening to that session. And again, please feel free to reach out to us and to discuss any of your requirements further. Thank you and have a good day.
非常感谢 Mr. Richter 的精彩演讲，让我们了解数位化生产。感谢各位的收看。若您希望获得更多市场拓销讯息，还请扫描画面中的 QR code， 获得更多本会办理的拓销团相关活动资讯。